Hello, and welcome to Impact AI, a podcast delving into how AI is reshaping industries and transforming decision making. I'm your host, John Hodges, and today we're exploring the next frontier of analytics in aviation AI that powers predictive maintenance, flight optimization, and smoother airport and airline operations control. Our guest is Victor Oribamise, CEO and co-founder of Kquika, a New York-based AI-powered aviation platform founded in 2021. Victor and his team built the award-winning Tracked system, a predictive aviation maintenance platform that analyzes real-time aircraft sensor data to forecast equipment failures with a 92 to 95% accuracy, helping airlines reduce unscheduled downtime by up to 30%. Kquika also developed the S system, a real-time airline service optimization platform that transforms passenger experiences. And third, Sans AI, a real-time insights, predictive analytics, and smart monitoring system for airport operations. Victor, welcome to Impact AI. How are
Uh,
you today?
I'm fine, John. Thank you for having me here. I do appreciate the opportunity to talk with you about what we are building at Quicker and what we think the future of the industry should look like.
Excellent. Give us a introduction to yourself, where your journey began in data analytics, and maybe a little bit of your path and what led you on the journey to found Kquika.
My journey started, back in when I was a very young boy, back in Nigeria. I grew up in Nigeria, so I'm originally from Nigeria, and I got introduced to the computer quite early. Also, I had a MacBook then. I think my dad gave it to me then. It didn't have a functional battery, so I could only use it, when there was electricity. So,
Mhm.
but that was kind of like I was introduced to the world of computing, and I discovered that when I power it on in front of people, people were impressed. I was like, interesting. So and then I started diving deep into how I could actually learn more about what is the world of computing and all of that. Because when people now had any technical problems, they would just call me that maybe I can fix it for them. And then I started learning more about Fortran. I started learning more about QBasic. And
Mhm.
then I started learning OOP languages. And then a friend contacted me, and it was like, I was a teenager then. So it was like, oh, Victor, can you develop an application? So the application was very simple. The idea was very simple, just to use the infrared idea. So, back then before we had Bluetooth, we had infrared. So infrared was kind of like a connection application, where you put one phone alongside the other phone to be able to exchange data or something like that. So the whole idea was, can we do that for emails? When people want to send emails, that, or can we just send emails in a particular IP location? So I was like, yeah, it should be possible. So I built it. Then I sold it for something very small. Then I think it should be under $20, but it was a very big money for me then,
Hmm.
because that was technically, the first time I earned money, so because I was living under my parents, they were taking care of me. I was a young boy. So, and then I was lucky enough to be born into a middle class family, so they could take care of me. So I didn't have to fend for myself. But that was the first time I made money. And and that was it. I was like, oh, interesting. I could actually make money. And then I got into college. And when I got into college, I wanted to go to school for medicine. Because, as you know, Nigerian parents, they only have, I think, three career paths for their kids. Either you're a medical doctor, you're an engineer, or you're a lawyer. So I wanted to be a medical doctor. And then I missed the cutoff, to get into med school by a point. And then I was like, I can't wait. So I had to just get into school, because I was like, I can't wait, I can't wait for another year and all of that. So I had to get into school. Then I got into college. And when I got into college and I watched, that was in 2011. Then this movie came out, social media, like about Zuckerberg building Facebook and all of that. Building the Facebook then. So we already had Facebook in Nigeria. So and then I I was like, interesting. If this boy could do it, maybe I could try something like that. So I built a forum with one of my roommates then. It too was into HTML4 back then. So it
Okay.
was HTML 4.0, CSS2, and all of that, before it became HTML5. So, and then Ayas. So both of us came together. So we built this small forum idea, replicating both Quora and Facebook into one. So the whole idea is we just update our classmates. Our classmates can chat about every class they take, uh, every test or upcoming tests, upcoming homework, and all of those things. So we got about 300 signups, in less than 3 weeks
Hmm.
on there. Uh, but the problem was now this is now a full-time thing. Maintaining the application is very difficult. We didn't have money. I mean, we were very poor. We were just college students, living on pocket money from our parents. So we didn't have any money to do anything. We had to buy the domain name and all the server, out of our pocket money. And then I told my parents, I was like, oh, hey guys, can I drop out so I can focus on this? And they were like, no, you can't drop out. And so I told my colleague, about it, and we had to shut it down. So we shut it down. So that was technically my first startup.
Okay.
Yeah, we didn't register it, but that was technically my first startup where we got many people to use our product. So and then uh, I had to finish college. After finishing college, I moved to the state. So well, we all moved to the state. My parents, everyone moved to the state. So I went to school for my master's in genetics in North Dakota. And then during that period, my project was predicting heritability. So that was it. And then I built a software that could potentially predict heritability of traits in progenies. So the whole idea was we gathered data set from 25, 30 generations ago, and we put it into the platform. So the platform we technically predict, what genes, partner A, partner B can make, if they both come together to make babies. So if you give us data into your 30 last 10 generations, 30 generations, but we use 30 generations, for comprehensive data, because you need a lot of comprehensive data to be able to predict things as detailed like this. So I built the software. I built the software in R. I didn't use Python or anything, so I built it in R. And then this works. So we're able to predict, what genes or traits can be inherited if so and so, if A and B comes together to make babies, or if C and D comes together to make babies. So, and then I came to New York for my PhD uh, at Cornell. So during the course of the pandemic, I was stuck at home like everyone else. So I started reading a lot, about, how the industry is affecting people. And luckily enough, I have a brother in the US Air Force. So he was in the maintenance sector. So he told me about, the government, loses a lot of money because of unscheduled maintenance, and how much money is lost per hour. On the government side, the government has about, I think, up to a 7,000 aircraft. And anytime a plane is down, the government plane are always down for about 30% of at any given point in time. So 30% of the planes are always down. So anytime a plane is down, it costs them about up to 30,000 US dollars. And on the commercial side, it costs up to, according to Boeing, it costs up to 10,000 US dollars. And then uh, Airbus, FAA, it costs between 3,000 to 8,000 US dollars. So that's a lot of money to be people are losing because of unscheduled maintenance. So and then I started researching. So I researched for a whole year about the problems of the industry. So I understood what the industry was. I'm an outsider, of course. So I talked to a lot of people in the industry and people that were willing to let me know exactly what's going on. So I learned a lot from them. So, and then we started Kquika. And then I told my co-founder. My co-founder was interested, was excited about it. So that was how we started Kquika. So that is the short story of how I came to this journey.
Okay. Interesting. So in during that journey, I'm sure you traveled quite a bit on the airlines, and I would assume that
Absolutely.
these real experiences and frustrations that you experienced inspired you um, in forming this tracked system.
Yeah, absolutely. Because there was a time I was stuck at an airport, because of unscheduled maintenance. I mean, the year now they were like, "Sorry, we just discovered a fault on our plane,
Right.
you know, and we are sorry. We'll let you know when we fixed. I will move as soon as possible. As soon as possible was like 12 hours, so I had to be stuck at an airport for 12 hours because
Yeah.
I didn't plan to spend more money, like I didn't want to leave the airport, so I was just stuck there. So I had to
Right.
just stop, and then I was just sometimes I wander around for 12 hours. I was stuck at a point. So that's one of the experiences, and then traveling, from Nigeria to across the world. I've been a victim of this problem, and then everyone who has been on a plane before, even pilots like yourself, they are also victims of this problem because they did not create this.
Right.
So victims of this problem. So that is kind of like that is one of the inspirations, to start the company.
Yeah. So, how does predictive maintenance, or why is predictive analytics such a game changer in predicting maintenance, and what makes the track system stand out?
I mean, so as as I said earlier on, I don't know if I mentioned the numbers, but to refresh on it, the industry spends up to 120 billion every year on MRO. So
Right.
for industry people, MRO is maintenance. I've forgotten. I forgot. But anyways, and about up to 20% of or 30% of that goes
Yeah.
into maintenance. So that is a lot of money, you know, maintenance, repair, and overhaul,
Yeah.
MRO. So that is about up to 30% of that 120 billion goes into unscheduled maintenance every
Yeah.
year.
Yeah.
That's very, very expensive. That's a lot of money to that they're actually losing because right now, a lot of the traditional approaches that we have are very reactive. So like you only fix things after they break, or you have to replace them on fixed schedules, that is, and then when you are replacing them on fixed schedule, you still have up to 40% useful life remaining. So you are still losing money, even if you are fixing them on a scheduled platform. But what makes our platform unique is very simple and very straightforward. One, we have a multimodal example approach. So our multimodal example approach is very simple. We first of all start with a degradation model selection. So based on each component part, we use fixes to be able to select, like what part will degrade faster. And then after doing the degradation model selection, then we move to our seven model example approach. So which is failure prediction model, component lifetime model, maintenance optimization, fleet optimization, supply chain model, and then anomaly detection. So for other people in the industry, they use singular model approach. They just kind of like do a one-to-many approach. But for us, we do a one-to-one approach. We try to segmentize all of these problems into all of these component parts, like predicting failure, understanding component lifetime approach, understanding maintenance optimization, understanding how we can
Yeah.
uh,
Yeah.
optimize it, supply chain, and then anomaly detection. So this actually gives us the opportunity to be able to achieve higher accuracy more than what other people are, actually, giving out.
Right.
So model is very high because of this combined multimodal approach. So we are not just looking at it from just one point of view alone. We're looking at it from an industry point of view, from an industry-wide point of view, that
Oh,
all of these factors, all of these conditions, they actually contribute to each plane breaking down. So we try to extract all of these conditions together and put them together. And so that gives us a higher accuracy more than the industry actually.
oh, I get it. I get it. That's a good explanation. Um, so I'm using that same tool. Kquika also offers optimization or service optimization via the S system, um, which I believe is um, going to be very welcomed. So how does AI help the airlines control the passenger logistics?
I mean, so this is what we started. This is our thought process around the system. So like we understand that people travel regularly, and then they love traveling with a singular airline. Maybe for example, I love traveling with, I don't want to mention airlines, maybe airline A. So if I love traveling regularly with airline A, I believe airline A should be able to understand me better when I travel with them,
Right.
because a lot of times. So their system helps the airline, identify, is Victor traveling for vacation right now? Or is he traveling, for a business trip? What time of the year does he travel for vacation? What time of the year does he travel for business trip? What time of the year does he just make random traveling? So if I'm traveling for vacation, I mean, of course, if I was married, I will actually, have other people coming on board with me because I'm traveling for vacation. And then there is a time for vacation. Most of the time, I always around summer or something like that. So Victor must be traveling for vacation around this time. So the AI system will be able to help the airlines identify that, Victor is traveling for vacation around this time. These are his needs. So I mean, no one wants to experience delays, but Victor can experience a couple of delays if it happens, compared to if he's traveling for a business trip. So he won't want to miss any he won't want to have any downtime when he's traveling for a business trip. When Victor is in the year, maybe Victor likes to get maybe 4 cups of coffee, or maybe he likes extra leg room and all of those things. Instead of instead of Victor asking the ELs tells that, hey guys, can you give me this? Can you give me that? The AI system puts that into consideration when I'm booking my ticket, which is kind of like the whole full integration that we are thinking about.
Mhm.
So when booking my ticket, the AI system will be able to ask me, will you love more coffee? Will you love liquor? Do you love Wi-Fi? When you're traveling around this time. And if I actually click yes, then that will be added to whatever my service charge should be, when I'm booking the ticket. Compared to, people not getting on board in the year and then they have to start asking, hey, do you have this? Hey, do you have that? Hey, don't you have this? Hey, don't you have that? So automatically, based on my previous traveling patterns with the airline and based on my previous purchasing patterns with the airlines, so airlines can quickly offer me hyper-personalized service recommendations in real time. So instead of, uh, I mean, air hostesses will still be needed, but this start making every passenger feel like a king.
Right.
So it won't be like a one-to-many approach. You know that I mean, if you travel international regularly, air hostess will have to ask you, do you want chicken? Do you want fish? Do you want that? Do you want this? No, that should not be. People, airlines should be able to identify, oh, this person is vegan, this person kosher, this person loves meat. So instantly, all of those things will just be like, we've gotten it already. Airlines know the PNR, personal name record of each passenger. They know
Yeah.
they know everything. So it should be easier for them to be able to match each seating number to each passenger. And then the services will be delivered to all of those seat number. So
Right. Right. Excellent. Um, okay. And then when implementing these products, they've already got, their infrastructure in place. Um, is there a challenge to introduce this type of software or platform to the
oh,
existing infrastructure?
no, I mean, so the whole idea is we connect directly to whatever infrastructure they have on ground via API. So we are not building a whole new system for them to start. I mean, we are not doing a rip and replace. So we are not doing a rip and replace in any way or form. All we are doing is we are trying to make it very easy for them to be able to plug into our system. One, we understand that they have these legacy systems. So legacy systems are already available. We are not trying to replace any of that. We are just trying to work with all of those legacy systems. And if we start doing rip and replace, how about all of the other different data format that we'll be receiving? How do we kind of like work with all of those things? All of those data formats. So all what we are doing currently right now is we are trying to make it very easy for our clients, to be able to use our technology. We plug into what platform they already have. Because in terms of maintenance, some of them use Amos, some of them use other platform
Yeah.
tracks. So we are not trying to replace any of those things. We are just
Right.
trying to help them. We are just trying to make it very easier for them to plug into all of those platforms. So
Right.
we have platform integration for both Amos and tracks, on our platform. So very easy for us to use, and it's a cloud-based operation. So we are not using any hardware. So they can, if they do want the front end, they can log in, they can have role-based access, role-based access control for anybody they want on board, so they can log in via a front end, or they can use our API platform. So very easy for us to use, very easy for them to use.
Yeah. Excellent. So, and talk a little bit about the SANS system. I know that optimizes, airport operations. Is that from the company level, or is that the entire, like, would that be a product for the airport in its entirety, or just major companies at the airport?
No, no, it's for the airport in its
Okay.
entirety. So it's not just for companies at an airport. If you think about, like resource optimization. So resource optimization is they want to understand, what gates will be available, for each
Yeah.
departing plane or incoming plane. So how do we ensure that we can better manage our resources, for all of this? For example, in terms of passenger, they want to know, what time will this terminal be congested? What time of the day are we expecting congestion? How many staff do we need, to manage this level of congestion?
Hmm.
When you go to each gate, and then each passenger is just trying to shout at each attendant, and the attendant will be like, "Oh, I'm trying to talk, I'm trying to talk, I'm trying to talk." They cannot effectively manage all of those passengers. Why? Because they did not have an understanding of, oh, this terminal is congested. Why is this terminal congested? Maybe there was a delay they didn't plan for. So now they have more people than they actually think they were going to have. So how do we manage our resources to be able to effectively tackle this problem that we didn't plan for? Maybe there's a weather change, the weather expect the weather to change drastically, and the weather just changes. How do we ensure that, planes don't collide into each other and all of those things? So it's a product that is built for the whole airport, as a whole.
Excellent. Okay. And looking ahead, what um, what AI or analytics types trends do you see reshaping aviation in the
No,
next 5 years? I mean, how do you see the impact of AI affecting the industry?
I mean, right now in the industry, a lot of the things that are being done today is mostly reactive. With our product, things will become predictive. And with the update that we have in the next couple of years, maybe 4 or 5 years from now, it will become prescriptive. So another thing I didn't mention earlier on is we have something that we've inbuilt into our predictive maintenance platform, the track system, which is what we call federated learning. So basically, if you are an airline with maybe 20 planes, you'll be able to benefit, as much as an airline with 2,500, 2,500 planes, on our platform. So federated learning is just ensuring that each airline on our platform can share insights with themselves, without actually sharing any data. So we've been able to train our model with a lot of privacy and robust privacy security and all of those other conditions that everyone on the platform can share insight or model weight, of whatever, when we train our model with your data set, we get some results. So we are able to put that into a big central system. So each person, either you have 5 planes, either you have 200 planes, you are sharing your model results with a big central system. You are not sharing your data. Your data is still yours, very private to you, very personal to you. And then you share the only result, the insight from all of that, with the big central system that we are
Right.
building. So what this does is, for example, for example, if let's say the hydraulic pump for maybe airline A fails after maybe three three trips, why for airline B it only fails after 2 trips? Why for airline C they've not even experienced that? So, but all of them will be able to have an insight into that. This problem is occurring to this particular brand of aircraft. Maybe it's happening to manufacturer B, manufacturer C, and so on and so forth. So if you're playing, as a component of manufacturer B, if you're playing as a component of manufacturer B and you are signing on a platform, we can give you insight into what is happening to other planes flying manufacturer B without giving you their data set. So you are able to better, prepare,
Right.
you know, all of these problems. So so that's kind of like one of the things, where we are seeing the future, so the future will become more predictive, more prescriptive, and then we will be able to help airlines, save you a lot of money, at the end of the day. So that is kind of where I think the industry is going to be. And then the industry become more data oriented. I mean, airlines generate terabyte of data daily. So we will be able to use, our technology to be able to help airlines, better understand, what's happening to each plane, no matter what type of plane it is. So, because another advantage of our platform is we are aircraft agnostic, so we don't have a manufacturer lock-in as other people. A couple of other people they build platform only for their own particular platform, so they don't have insight into what's happening to other aircraft type or model, but our platform has that advantage. So that's
Right.
kind of like.
Yeah. Excellent. Fantastic. Okay. Well, we have gone through all our questions. Is there anything else that you wanted to expand on?
I don't know. I just think I just think with the product that we have, I think with all our products will be able to, help the whole ecosystem, because when the track system knows, what planes will break down, we can better communicate that with airports that are on our platform via this sound system that you can better manage the resources for tomorrow because we have data and insight into all of these. And then
Right.
better help, and then via that, airlines can better help their passengers that, hey guys, we might most likely, have some, breakdown tomorrow. So, and then they'll be able to, help their their passengers will feel more, I don't know, more responsive. And then their passengers will be like, oh, these people are thinking about me. Because if you ask a lot of people think, airlines don't care about them.
Hmm.
So a lot of people think so. So, and I think our product, we actually change that because airlines will better understand the passengers on a one-to-one level. It won't just be like, oh, we are just trying to just push everything out all at the same time. So it will be a one-to-one approach, for all of their passengers. So their passengers will feel more seen, using today's term, will feel more seen. They will become more they will actually know that the airlines care about them, not
Yeah.
just
Yeah.
the money from them. So, and then I think through that, airlines can make a lot of money because if with our product, the industry can reduce how much money they spend on us, it'll be at least 50%. So that money will go back into their pockets, and then they'll be able to have more money to spend, on innovation and every other factor.
Excellent. I agree, 100%. And okay, well, wonderful. Well, Victor, this has been truly an illuminating discussion. You've shown how AI-powered analytics are not just futuristic tools, but they're helping airlines optimize the spectrum, maintenance, safety, cost reduction, and then the airports as well manage operations more intelligently. If you'd like to learn more about Victor and his product, where can they most likely find you?
I mean, they can find me on LinkedIn, Victor Oribamise. They can also send me an email, victor@quika.com. So I respond to my email in like 15 minutes maximum. So they can find me on there on both LinkedIn and via my email.
Excellent. All right, and for our listeners, if this has shifted how you think about AI and aviation, subscribe to us and share it with your network. So we'll see you next time on our Impact AI podcast. Thank you very much.